Alright, welcome to Absolute Value and Inequalities. For this video, we're going to talk about the absolute value, we're going to talk about inequalities, and then we're going to talk about the absolute value and inequalities combined. So first off, what is the absolute value? To solve problems that include absolute value signs, you must think of the problem as actually being two equations, one of them being positive and one negative. So this is what we're talking about. Those straight lines on the side of x plus 3, those are absolute value lines. And so the way you'd read this is the absolute value of x plus 3 equals 5. So what that means is x plus 3 equals 5 and or negative x plus 3 equals 5. So oftentimes you're going to have multiple values of x for these problems. Like this one, for example, x could be equal to 2 or it could be equal to negative 8. Eliminate the absolute value marks eliminate the positive or negative sign at the end. So another way you could think about it is this way. X plus 3 equals 5 or x plus 3 equals negative 5. So whichever way your brain works is totally fine. And I was taught this first way up here, but whichever way works better for you works fine. Now on the DAT, you will probably only see the absolute values tied to inequalities or within the same equation as an inequality. So let's talk about those. Inequalities. Inequalities include at least one of these symbols: less than, greater than, less than or equal to, and greater than or equal to. And if this is something you've had a hard time remembering in the past, the way that I remember these is that the side with the larger opening on it is the larger side. So to solve inequalities, we follow the golden rule of algebra. Whatever you do to one side, you must also do to the other side. And the end goal is to isolate the variable. So here's an example. 3x minus 5 is greater than 2. So the way that we solve this is same as anything else in algebra. First, let's add 5 to both sides and then divide by 3. And that gets us to x is greater than 7/3. So we successfully isolated x and solved for x. Now sometimes there's going to be inequality symbols on both sides of x. So let's talk about that real quick. For example, x is greater than 21 and less than 25. And the ways that you can read this is one of two ways, how I read it, which was x is greater than 21, because it's greater over here, and less than 25. Or you can say 21 is less than x, which is less than 25. But that doesn't really make sense in my brain, so I usually just say x is greater than 21 and less than 25. And the test creators can absolutely give you an inequality in this format and require you to solve for x when it's an equation. So this one, x squared plus 3 is greater than 12 and less than 52. So the way that you solve these is still using the golden rule, but now it's not what do you do on one side, you do the other. Now it's whatever you do on one part, you do to all three parts. And again, the goal is still to isolate x. So for this one, we should subtract 3 first. From all three parts. Then that gives us this, x squared is greater than 9 and less than 49, and now we take the square root. And boom, there's our answer, x is greater than 3 and less than 7. And you can always plug in a number that's within that range into that first equation to make sure that this is correct. So let's pick a random number real quick to check it. 5 squared plus 3 would be 25 plus 3, which is 28. 28 is indeed between 12 and 52, so you're good. Sometimes it's worth checking your answers if you can do something like that in a couple seconds, just to make sure there were no silly errors on the way. All right, now absolute values and inequalities when used together. The DAT especially likes to use questions like this because they're testing two different things, absolute values and inequalities, at the same time with just one question. So it's a very efficient way to test you. So let's solve this one together. First, let's get rid of the absolute value markers by transforming it into an equation with 3 parts. So the absolute value of 2x minus 5 is less than or equal to 7 becomes 2x minus 5 is between negative 7 and 7. Let's isolate x. The way that I would do that is first add 5 to each section. That gives us 2x is greater than or equal to negative 2 and less than or equal to 12. Now divide that all by 2. And that gives us that x is greater than or equal to negative 1 and is less than or equal to 6. So really quick to plug in and check, you can plug in 0 times 2 is 0, minus 5 is negative 5, absolute value of negative 5 is 5, and that is less than or equal to 7. 5 is less than 7. So we did it. Now, tricky rule for inequalities. If you ever multiply or divide by a negative number, you flip the sign. So if you had greater than, and then you divide by -2, let's say, you flip it to be less than. And I'll show you an example of this. And make sure you memorize this rule because I can't guarantee, but if I could guarantee, this is the closest thing to a guarantee that will be on the test. -2x is greater than 10. The first step would be to divide each side by -2, right? And when we divide by a negative number, we flip it. So now it is x is less than -5. And again, you can check it with math to make sure that this is right. And so if we use x is -10, let's plug that in there. -2 times -10 is 20, and 20 is greater than 10. So it's right. If you forgot to flip the sign, that final answer would have said x is greater than -5. If you would have done that, you could just plug in the number 0 to test it, right? And you could do -2 times 0, which is 0. 0 is not greater than 10. So now you have this red flag that comes up and you're like, hey, hold on, I just solved it, but when I check my answer, it doesn't work, so something's wrong. Just make sure that you're flipping the signs when you're supposed to. And that's another good reason to check your answers when working with inequalities because it doesn't take long and it can save you from making silly mistakes. All right, here's our summary slide for you to take a picture of. I'll see you in the next one.